All right, let's get started with 7.5, solving radical equations. So that's all we have to learn, just one thing, solving radical equations, and so the only vocab is radical equation. But before we get to that, let's do some skills checks here. So solve by factoring. I'll do the first one, you'll be responsible for the rest. To solve by factoring, we need to get everything on one side. So we could add x and minus 6 and leave 0 on the right. And then we ask ourselves, what multiplies to negative 6? And adds to 1, positive 3, and negative 2 equals 0. So then both terms equal 0. X plus 3, actually don't need the parentheses anymore. X plus 3 equals 0. X minus 2 equals 0. X equals negative 3. Or x equals positive 2. So pause the video, do the rest of those, 2, 3, 4, 5, and 6. And when you're done with those, press play, and we'll keep going with radical expressions. Radical equations. All right, so a radical equation is any equation where you have a variable in the radicand. So like this one, we've got x as the radicand, so anytime the variable is the radicand, it's a radical equation. Or if we have a variable that's being raised to a rational exponent, okay, something with a fraction in it. All right, so we'll notice that even though we have a square root and a variable in this one, it's not a radical equation because it's not the x that's under the square root. All right, so that's what we need. And just a reminder here that if you have the n root of x equals k, then you could multiply both sides by the nth exponent to cancel that radical, the radical sign out, and we're left with x by itself. All right, so that's what we're going to use here for example 1. So our job first is to get the square root by itself, so we're going to minus 2 on both sides. We're left with the square root of 3x minus 2 equals 4. And then our job is to cancel out the square root, so we need to square both sides. On the right, we get 16. On the left, the square root cancels the square, and we're left with 3x minus 2, just whatever was underneath the square root symbol. We're going to add 2 and get 3x equals 18, and so x equals 6. And we've solved the problem. All right, so you do understanding check 1 and see if you can solve for x. All right, example 2. We don't have a square root, but we still have a radical equation, the 2/3. So first thing we're going to do is get rid of the 2. So we've got x minus 2 to the 2/3 equals 25. And then the way we're going to cancel this out is with reciprocals. To get rid of raised to the 2/3, we're going to raise both sides to the 3 halves. So then we're going to cancel here and be left with x minus 2 equals 25 to the 3 halves. And remember, that's the same as saying x minus 2 equals, the bottom is what the index is, the square root of 25 cubed. All right, so 25 cubed, we could grab our calculator. And we could actually go straight to this if we wanted to. 25 to the 3 halves gives us 125. So we'll come back over here. X minus 2 equals 125. So x minus 2, or x equals, add 2, 127. All right, and our job is done. Your job, number 2, get x by itself. All right, let's check out our real-world connection with square roots. So, company manufactures solar cells that produce 0.02 watts of power per square centimeter of surface area. A circular solar cell needs to produce at least 10 watts. What is its minimum radius? Okay, so remember that area is pi r squared, okay? And so we need 10 divided by 0.02. 10 divided by 2 is 5. 10 divided by 0.2 is 50. 10 divided by 0.02 is 500. All right, so we know we need at least 500 square centimeters here. And so we need to get r by itself. 500 over pi equals r squared. How do we cancel out r squared? We're going to square root both sides. And let's figure out what the square root of 500 over pi is. Back to our calculator. 500 divided by pi is 159. And let's square root that. So to the 0.5. And we get 12.61. So the radius needs to be at least 12.61 centimeters. All right, so same steps here, but find it for 20 watts of power instead of 10. All right, so sometimes we're going to have extraneous solutions. And what that means is we'll get to the end and say x equals something, but when we plug it back into the beginning, that answer won't work. And this will happen if we have to square both sides. We have x's on both sides. So you'll see that in a second here. And so what we need to do here, let's minus the 5. X minus 3 equals x minus 5. So that the square root's by itself. Let's square to get rid of it. But then we need to square the other side. So that's going to involve foiling. So now we're going to have x minus 3 equals, if we foiled this, x squared minus 10x plus 25. And now we need 0 on one side. So this is where the skills check comes in. X squared minus 11x. And we're going to add, so plus 22. And so how do we get to 22 and add to 11 here? No, subtract to 11. 22 is 11 times 2. What am I missing? Hold on a second. Let me pause this. Oh, there's my foolish mistake. When we add 3 to both sides, we don't get 22, do we? We get 28. All right, 28 is a 4 and a 7. X minus 4 and x minus 7. And so x equals 4 or 7. However, when we plug it back in, let's go ahead and check this. If we plugged in 4 back here, 4 minus 3 is 1. The square root of 1 is 1. And 1 plus 5 is 6. Okay? And it was supposed to equal 4. So the 4, no good. Let's check the 7. What happens up here if we plug in 7? 7 minus 3 is 4. Okay? The square root of 4 is 2. What's 2 plus 5? 7. Okay, so the 7 works out. The 4 did not. So the 4 is an extraneous solution. All right, see if you can solve number 4 and make sure to check for those extraneous solutions. And last one here, we're going to do the same thing, checking for extraneous solutions if we have to. So we're going to add the second term, and I'm going to write this as a 1/2, just easier to see, equals 3x plus 4 to the 1/4. Okay? So on that one, how are we going to get rid of the fractions here? Let's multiply them all by 4. Power of 4. That's going to cancel them out. But here on the right, what's half of 4? 2. So we're still squaring. 1/4 of 4 is just 1. So the exponents go away on the right. We're going to have to FOIL here. We're going to have 4x plus, 4x squared. 2x times 1 is 2x. Twice is plus 4x plus 1 equals 3x plus 4. Okay, so let's subtract 3x. So we'll have 4x squared plus 1. And let's subtract the 4, so minus 3, 1x in here, equals 0. And so let's factor this. We know we're going to have a 3 and a 1 here. And what would we need on the other side? We would need a 4x and a 1x here. 4 times 1 needs to be the positive 1. 1 times 3 is the negative 1. That equals 0. So x equals negative 1 or 3/4. Let's go back and check these. So really quickly, negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 1. Negative 1, the square root of negative 1, that's not going to work. Can't do square roots of negatives. Let's check 3/4. So if we go back up here and plug in 3/4 times 2 is 1.5. Plus 1 is 2.5. So we've got, let me just rewrite what we've got. 2.5 to the 0.5 minus 3 times 3/4 is 2.25 plus 4 is 6.25 to the 0.25. And let's go ahead and plug these into a calculator and see what we get here. 2.5. Get rid of that. Where's our calculator? 2.5 to the 0.5 is that 6.25 to the 0.25. Oh, exact same thing. So that one does work. All right, so 3/4 is a correct solution. All right, last one for you to try there. Try to solve number 5. Check any extraneous solutions you come up with. And any questions, we'll go over this in class. Good luck.